Welcome to Vision Plus and welcome back to this S.4 Mathematics. We are looking at normals and tangents to curves. Example 4 says, find the equation of the tangent and the normal to the curve. The curve is y equals to x cubed plus 2x squared plus 3x at the point 1 and 4. So let us start with the equation of the tangent. For us to get the equation of the tangent, we need the gradient of the tangent. And the gradient of the tangent at the point of tangency is the same as the gradient of the curve. So let us get the gradient of the curve. So we differentiate the equation of the curve so that we can get the gradient function of the curve. So dy dx becomes 3x squared plus 4x plus 3. This is the gradient function of the curve. After getting the gradient function of the curve, then we use the point of tangency to get the gradient of the curve at that point. Therefore, dy dx at the point 1 and 4 equals to, we substitute for x in the gradient function. So this is x, this is y. That means we shall have 3 times x, which is 1 squared plus 4 times x, which is 1 plus 3. That gives us 3 plus 4 plus 3. This gives us 10. So this is the gradient of the curve at the point of tangency. And we know that at the point of tangency, the gradient of the curve is the same as the gradient of the tangent. So the gradient of the tangent is also 10. Remember, the gradient of the curve at the point of tangency is not the same as the gradient of the normal, but it is the same as the gradient of the tangent. After getting the gradient of the tangent and we know one point on the tangent, then we can find the equation of the tangent. So the equation of the tangent either way, it now becomes, this is the gradient n of the tangent, this is x, y. The tangent is a line, therefore 1 equals mx plus c. Then we substitute. Our y is 4 equals to m is 10 times x is 1 plus c. Then we get c. Our c here becomes negative 6. Remember, c is the y-intercept. So after getting c, then we come back and substitute for n and c, and that is the equation. Therefore, the equation of the tangent becomes y equals to n. N is 10, x plus c, but c is negative 6. That is the equation of the tangent. After getting the equation of the tangent, we need to find the equation of the normal in part A. What do we know about the normal and the tangent? We know that the gradient, we know that the normal and the gradient are equation of the normal. We know that the normal is perpendicular to the tangent. So we can use the concept of perpendicular lines here. What do we know about two perpendicular lines? We know that the product of their gradients is negative 1. That means the gradient of the first line m1 times the gradient of the second line m2 gives us negative 1. So let me call the gradient of the tangent m1. Therefore, 10 m2 equals to negative 1. This gives us the m2 as negative 1 out of 10. This is now the gradient of the normal. Remember, the point of tangency is being shared by the curve, the tangent, and the normal. That means this point is also on the normal line. Therefore, we have the point 1, 4, and we have the gradient of the normal, which I can call m, -1 out of 10. The normal is a line. Therefore, y equals mx plus c. That is the equation of the line. This is x, this is y, this is m. So we can find c, where we are saying c is the y-intercept. So from here, we say 4 equals to m, -1 out of 10 times 4, times x, which is 1, plus c. Then from here we can find c. So c, 1 divided by 10, -1 divided by 10, we take it that side, it will be addition, so plus 4. So I'm getting c equals to 41 out of 10. This is the y-intercept. So we can substitute for m and c, and then we get the equation of the normal. Therefore, the equation of the normal becomes y equals to -1 out of 10 x plus 41 out of 10. And this is the solution to part A.